Let's take a closer look at the floating trash challenge and what you are going to need to know to develop a successful design. The challenge asks you to build a boat out of a few sheets of paper, some tape, and part of a transparency. And the boat has to hold as much weight as possible. Did you ever wonder how a cruise ship can be that big and still float? Well, there are three things about that cruise ship that you need to know, and those three things will help you get the most out of your paper boat. They are mass, volume, and density. As you may already know, mass is the amount of material in an object, and is measured in grams and kilograms using either a scale or a balance. Next is volume, and no, not the volume on your iPod. In this case, volume refers to the amount of space an object takes up. For our purposes, let's look at a box. To find the volume of this box, we would multiply the length, width, and height together. Third is density. Now simply put, density is how tightly packed the material in an object is. Now take a look at the two cubes. Now the cubes take up the same amount of space. That is to say, they have the same volume, but the box on the left has more stuff in it. Notice that because there is more in the box on the left, the red balls are closer together. This means the box on the left has a higher density. Another way to think about density is that density is just a relationship between an object's mass and its volume. To calculate density, we first need to know an object's mass and its volume. Now let's say this box has a mass of 6 grams and the volume of 12 cubic centimeters. We can check the volume by multiplying the three dimensions of this box. 2 times 2 times 3 equals 12, and our units are cubic centimeters. Now, to find the box's density, we take the mass and divide it by the volume, and that gives us a density of 0.5 grams per centimeter cubed. Let's look at another example. This box has the same volume as the last one, and we can check that by multiplying the dimensions. 2 times 2 times 3 is 12 centimeters cubed. The difference is that this box has a mass of 18 grams, and if we use our density formula, we see that this box has a density of 1.5 grams per cubic centimeter. By increasing the mass, we increase the density. But what happens when we keep the mass the same and change the volume? Here we have two boxes, both with a mass of 8 grams, but box A has a volume of 10 centimeters cubed, and box B has a volume of 5 centimeters cubed. Well, what does that mean for their density? I'm glad you asked. When we use our density formula, we find out that box A, even though it is bigger, has a lower density. How can that be? Think of it this way. Imagine a brand new bag of potato chips. Now before you open the bag, there's all kinds of empty space that the chips can move around in. That's box A. Now, open that bag, let the air out, and close it back up. But don't take any chips. The bag has the same amount of chips in it, but now it takes up less space. That's box B. Same amount of stuff in it, but less room for it to move around. You're probably thinking, oh, this is great, but what does this have to do with my paper boat? And now I want some potato chips. Well, hold on, I'm getting there. Now you may remember from science class that the density of water is 1 gram per centimeter cubed. This is our magic number. Any object that has a density less than that will float in water, and any object that has a density more than that will sink in water. Here's where your boat comes in. If an object's mass is larger than its volume, then the object's density is greater than 1 gram per cubic centimeter, and it will sink in water. But if an object's mass is less than its volume, then the object's density is less than 1 gram per cubic centimeter, and it will float in water, just like our cruise ship. And that means if you increase the volume, that is, take up more space with your boat, without increasing the mass, you will decrease the density of your boat, which means your boat will be able to hold more weight, and you might just be able to avoid ending up like the Titanic. Good luck.